Okay, so we are going to continue on. We're going to finish up section 1.3. So this will be wrapping up section 1.3. So first example we're going to work on here is going to want us to simplify. And they give us negative 8 plus square root of negative 128, all that over 4. So when we go through to do this, step one, if we want to simplify something like this, we have to get the part under the square root to be positive. So I need to put a I out front. Now that we have this positive value, we can start simplifying this square root down. This is a perfect square of 64 times 2. So square root of 128 we could rework as square root of 64 times square root of 2. So what we get is negative 8 plus I, square root of 64 is 8, square root of 2, all that over 4. So to finish up, we could say this is negative 8 over 4 plus I times 8 square root of 2 over 4. 4 cancels into 8, leaves a 2, so that's negative 2. 4 cancels into 8, leaves a 2. And normally a textbook will write the 2, the I, and then put the square root part. So I'm just going to kind of reorder the I and the 2. And that should be fully simplified at this point. So basically just make sure that you get the you pull an I out front to make sure that the square root part that you're dealing with is positive. And then you're able to just go through and simplify it down like you would with a regular root. So the next group of problems is going to have us add and subtract some complex numbers. So we're going to say for part A, they give us 3 minus 4i, and are telling add it to negative 2 plus 6i. So for this, there's nothing to distribute out front here, so we can drop this first group of parentheses. So when we go to solve this, we can say, all right, this is going to equal just 3 minus 4i. And then we add to it. Again, there's nothing to distribute out here, so we just add to this negative 2 plus 6i. And then what we're going to do is we're going to add the real parts together. So we add the parts without the i's together. So we have positive 3 and a negative 2. So positive 3 plus negative 2 is a positive 1. And we add the parts that have just the imaginary parts, which are the parts with the I. So I have negative 4 i's here, plus 6 i's. Negative 4 i's plus 6 i's is positive 2 i's. So that is how we solve part A. Part B gives us some complex numbers, but it's a subtraction this time. So we get that minus this. So for this one, we go to solve it. Again, there's nothing to distribute out here, so we can just drop the first set of parentheses. In the second grouping, however, the negative distributes. So we get a plus negative 6 minus a negative is going to be positive 7i. So we distributed out the negative. Then, now that we've got this, the first set there was nothing to distribute, so it just dropped. Second set, distribute the negative. Now we add the real stuff together, so negative 4 plus negative 6 is negative 10. And we add the stuff with the i's, which is the imaginary stuff, we add them together. 3 i's plus another 7 i's is plus 10 i's. Okay. So that'll do it for addition and subtraction. Next up, they want us to multiply a couple things. So, oops, hang on. Pen's acting a little weird here. So let's say, for our next example, we want to go through and multiply some stuff. They give us 2 minus 3i is getting multiplied by 3 plus 4i. And that's our part A, is do this multiplication. So we'll work this out, then we'll do part B. So we're just going to kind of FOIL stuff out. 2 times 3 is 6. 2 times 4i is plus 8i. For the inner terms, negative 3i times a 3 is negative 9i. Negative 3i times positive 4i is negative 12i squared. We want to remember I squared is really negative 1, so negative 12 times I squared is the same as negative 12 times negative 1. And the effect is the I squared will flip the negative 12 over to a positive 12. And now at this point, we add the real parts together, which is the parts without the I. So 6 plus 12 is 18. And we go through and we add the imaginary parts, which are the parts with the I. We have 8 i's plus negative 9 i's. 8 plus negative 9 is a negative 1 I, so that is a negative I. So that's part A. Part B wants us to go through and solve out 4 plus 3i squared. They want us to simplify that on down. So step 1, when you square something out, that means multiply it by itself. So we'll just say, all right, we get 4 times 4 is 16, plus 4 times 3i is plus 12i, plus 3i times 4 is plus another 12i, plus 3i times 3i, 3 times 3 is 9, I times I is I squared. Again, I squared is negative 1, so positive 9 times negative 1 is a negative 9. We add the real parts together. 16 plus negative 9 is 7. Then we add the imaginary parts together, which 12 i's plus another 12 i's is plus 24i. That's basically it. We stop there and say that will be our solution. So multiplication's not too bad. You just have to remember I squared equals negative 1. And then you just add real parts and imaginary parts together. Next up, we get this concept called a complex conjugate. So we'll say the complex conjugate of a plus bi is a minus bi. So for this example, we'll just say find the complex conjugates. So let's say part A is 5 minus 7i, part B is negative 2 plus 3i, and part C is 6i. So all we have to do is switch the sign on the imaginary part. So 5 minus 7i has complex conjugate 5 plus 7i. And negative 2 plus 3i has complex conjugate negative 2 minus 3i. Just switch the sign on the part with the I. Positive 6i has complex conjugate negative 6i. So what we want to do is there's a nice property that a number times its complex conjugate has. So let's look at 5 minus 7i times 5 plus 7i. Let's try to FOIL those two out. Those are complex conjugates of each other. And let's see what happens. So if we FOIL this out, we get 25. Outer is plus 35i. Inner is minus 35i. Last would be negative, see 7 times 7 is 49, I times I is I squared. So negative 49i squared is going to become positive 49 because I squared is negative 1. Positive 35 and negative 35 add up to nothing, they cancel out. So we get 25 plus 49 should be 74. And the nice thing about this is we started out with two terms with i's in it, and this term down here has no i's in it. So that's a nice little property. If you multiply a number by its complex conjugate, you lose imaginary parts, which we're going to need to use in just a minute here. So a nice property we could say is if you have a plus bi and you multiply it by a minus bi, the complex conjugate, this equals a squared plus b squared. So this is a nice little Nice little formula, or nice little note. Basically, we can see that was true here. A was 5, B was 7, so we got 25 was 5 squared, 49 was 7 squared, 25 plus 49 is what we ended up getting for our result. Okay, so let's look at division types now, and then we'll look at powers of I to finish up the section. So division types for this example. We were going to look at 3 plus 2i, all that divided by 5 minus I. Told to simplify that, which means get it down to the form a plus bi. So what's causing the problem here on this one is the denominator has an I in it, and we need to get that I gone. So we just talked about a second ago the complex conjugate, which says if we multiplied that by its complex conjugate, then the i's in the denominator would be gone. But if I do it this way, that unbalances the problem. So what I have to do is multiply the top by the same amount to keep the problem balanced. So when you do a division type, you find the complex conjugate of the denominator, you multiply both the top and the bottom by the complex conjugate of the denominator. From there, it's just FOIL out the top and FOIL out the bottom. So we get 15 plus 3i plus 10i plus 2i squared. And down here, we'll get 25 plus 5i minus 5i minus I squared. So 2i squared up here becomes negative 2. Negative I squared becomes a positive 1. Positive 5 and negative 5 add up to nothing. So we're able to go through and kind of simplify our stuff down. 15 take away 2 is 13. 3 i's plus 10 i's is 13 i's. That's all over 25 plus 1 is 26. These all share a common factor of 13, so we're going to divide the common factor of 13 out. You have to divide it to all three places there. And we get 1 plus I, all that over 2 for our answer. Okay. Should note that this right here is the same as 1/2 plus 1/2 I. So you could say it's 1 over I plus, this would be I over 2, which is the same as 1/2 I. So either form, that form or this form, they're equivalent. Okay, so we got that example. We got one last division type. We say, what if they gave us a 3 over I? Tell us to simplify. So the complex conjugate of I is a negative I. So we'll multiply both the top and the bottom by negative I. This will give me negative 3i over negative I squared. I squared is negative 1, so negative I squared is positive 1. So we'll have negative 3i over 1, which is negative 3i. Okay. Now for the final example, they want us to... let's do it this way. Let's look at powers of I. So if we have I to the 0 power, that's 1. I to the first power is itself I. I squared is the same thing as negative 1. I cubed, we could say that's the same as I squared times I. I squared is negative 1, I is I, so this is negative I. I to the fourth, that would be I squared times I squared, which is negative 1 times negative 1, which is positive 1. I to the fifth is I to the fourth times I. So I to the fourth is 1. I is itself I, so that becomes 1 times I, which is I. I to the sixth is equal to I squared times I to the fourth. I squared is negative 1. I to the fourth is positive 1, so that's negative 1. I to the seventh equals to the fourth times I cubed. I to the fourth is 1, I cubed is negative I, so this is negative I. And then the pattern repeats. So I to the 8th will be 1, I to the 9th will be I to the 10th will be negative 1, and I to the 11th will be negative I, and it keeps going on like that. So what we want from this, or a nice property that we have, is if you have I to the power of a multiple of 4, that is going to equal 1. So that's a nice property. We're going to use that to do our final examples. So we say for this example, part A, we want to find what's I to the 77th. So what I'm going to do is think of what's a nice multiple of 4 that's inside of 77. So I'll say like I to the 60. So it'd be I to the 60 times I to the 17th. Since I to the 60 is a multiple of 4, this is really 1. So 1 times I to the 17th is just I to the 17th. Now I need another multiple of 4 inside of I to the 17th. So I could say, well, 16 is a multiple of 4. So I have I to the 16th times I. Since 16 is a multiple of 4, I to a multiple of 4 is 1. This just becomes I. So let's say we had I to the 114th power. 100 is an easy to work with multiple of 4, so I'll say this is I to the 100 times I to the 14th. So I to the 100 is really just 1. 14, we could say 12 is inside of 14. That's a multiple of 4. So we get I to the 12th times I squared. I to the 12th is 1. I squared is negative 1, so this is 1 times negative 1. Gives you back negative 1. In all of these larger powers, we're trying to get our solution down to 1, I, negative 1, or negative I. If you have a negative number, say like I to the negative 29, what we'll need to do is we'll say, well, if we have I to the negative 29, I to the negative 29 times 1 should still be the same thing as I to the negative 29. And since I to a multiple of 4 is 1, I'll just need to bring in a larger multiple of 4 than negative 29, and then I can figure out what I'm actually dealing with. So I have I to the negative 29. 32 is 8 times 4, so I'll say I to the 32 is the multiple of 4. I'm rewriting 1 as. Negative 29 plus 32, that would be I to the 3rd. And I to the 3rd from the little chart up there is negative I. So for negatives, you just bring in a multiple of 4 that's larger than the number you're dealing with, and then you can simplify it down from there. And that's going to basically wrap up section 1.3, so we'll stop there on the note.